Chemists often need to relate quantities of reactants and products. We use the information from the balanced chemical equation to help us do this. So here's a balanced chemical equation, and you notice what we're going to be looking at here are the coefficients. Now, if I'm talking about molecules, I could say that 1 molecule of nitrogen reacts with 3 molecules of hydrogen to make 2 molecules of ammonia, or NH3. But we've talked about before, molecules are very small. We can't really measure 1 molecule in the lab when we're working, and so we upsize it. And by upsizing it, I mean instead of taking 1, we take like a scoop, not just any general scoop, a mole. So these coefficients can be related to molecules, but they can also be related to moles. So notice this is not a calculation. I have a 1 coefficient here, so I can say instead of 1 molecule, I say there's 1 mole of nitrogen. And the 3 here, instead of 3 little molecules of hydrogen, I say 3 moles. And the 2, instead of 2 molecules of ammonia, I say 2 moles. So I upsized it because we know moles are something we can measure in lab. Now from these moles, what helps me is making something called a mole ratio. Again, this really isn't math. It simply is putting the different coefficients on top of each other. So for example, I could compare the moles of nitrogen to the moles of hydrogen, and I get 1 to 3. Now this ratio could also be written in the reverse. I could put the 3 moles of hydrogen on the top and the 1 mole of nitrogen on the bottom. What will determine which part I put on top and bottom will be what I'm given once we get our problem. Now, maybe I want to compare the nitrogen, one of the reactants, to the ammonia. So this has 1 mole of nitrogen because there's a 1 in front of the nitrogen, and 2 in front of the ammonia because there's 2 in front of the ammonia here. So it's not a calculation, it's simply taking the coefficients and rewriting them as a ratio. Now again, there may be a case, depending on what I was given, that the 2 moles of ammonia would be on the top of the ratio and the 1 mole of nitrogen would be on the bottom. Now finally, there's one more ratio I can get from this equation. I have 3 moles of hydrogen. I could compare the hydrogen to the ammonia. So it'd have 3 moles of hydrogen to 2 moles of ammonia. Again, I could write the 2 moles of ammonia on the top and the 3 moles of hydrogen on the bottom. It will simply depend on what problem I'm given, because just a hint, it's going to depend what you're given, it's going to depend on what you want to cancel. So here's an example of how we might use this. So it says, the question says, use mole ratios to convert the number of moles of A to the number of moles of B. So that's being kind of general. And here's our equation. Now, if there's no number, we know that those are going to be 1s. And this, in front of the NO, we have a 2. So let's look at letter A first. So A, we're trying to calculate NO. So we want to find this. And they tell us we have 3.3 moles of nitrogen, which is that. So you write down what you have. I have 3.3 moles of nitrogen. And to figure out how nitrogen relates to NO, I'm going to multiply it by the ratio. So here's where I know, or how I figure out what to put on the bottom. If this is nitrogen here, whatever you're given, its ratio will always go on the bottom. So it's 1 in front of that, so it's 1 mole of N2. And the thing you're looking for, in this case NO, that will always go on the top. So let me repeat that. The part on when you're writing the ratio and you're trying to solve a problem, whatever substance you're given, that will always be in the denominator or the bottom of the ratio, so it cancels out. Whatever substance you're looking for will always go on the top. So here the nitrogen cancels out, and I see that I get 6.6 moles of NO. So what I figured out is if I start with 3.3 moles of N2, in the course of a complete reaction, I would end up with 6.6 moles of NO. Now usually in lab we would need to know grams. If I had to convert moles to grams, then I would go back and use the molar mass to do that conversion. So let's look at this letter B, and I'm going to erase this so I have less writing. Alright, so let's look at letter B. So letter B says, I'm figuring out the moles of NO. So that's where I want to figure out. This is what I don't know. From 0.5 moles of oxygen. So there's a 1 here, and this is what I was given. So you always start with what you're given. So 0.5 moles of oxygen. Now, since oxygen was given, I'm going to write its ratio on the bottom. So that's the 1. So 1 mole of oxygen. And I'm looking for NO, so I'll put the 2 moles of NO. And 0.5 times 1 is 1. So in this case, 0.5 times 2 is 1. In this case, if I started out with 0.5 moles of oxygen, I would end up, after a complete reaction, with 1 mole of NO. So if you take what you're given and multiply it by the appropriate ratio of the two substances, you can determine the amount that you will make or use. So letter C says, I'm looking for the moles of oxygen. So this is what I'm looking for. And this time it gives me 1.2 moles of N2. Oh, that's this one here. So I say 1.2 moles of N2 is what I'm given. And when I set up my ratio, what I'm given, the N2 has a 1 in front of it. I put that on the bottom, so it will cancel. See, so that cancels with that. And then I'm looking for oxygen, so that also has a 1. So this is a 1-to-1 ratio. So if I have 1.2 moles of nitrogen to react with that, I would need 1.2 moles of oxygen. Now again, remember, just to incorporate what we were doing in the last video, if I wanted to go to get the grams, remember, if you have moles and you want to go to grams, you want to use the molar mass. Why don't we try one of these just so you can see? So let's do this one, the 6.6 moles of NO. So to find the grams of 6.6 moles of NO, remember moles, 2 grams, you're going to use molar mass. And the molar mass on this you find on the periodic table. This is a pretty easy formula. It has N, which has the mass of 14.01, and oxygen is 16 from the periodic table. They're not numbers we memorize, on purpose anyway. And I get 30.01 grams in 1 mole. So to calculate the number of grams, you take what we know. We knew there was 6.6 moles of NO. We want the moles to cancel, so we'll put the 1 mole on the bottom and the 30.01 grams on the top. So in a reaction, if I made 6.6 moles of NO, that would be, oh my goodness, a lot of grams, 198.066 grams, almost 200 grams. To two significant figures, well, this would round to 200, so we would have to say 2.0 times 10 to the second grams, and for two significant figures. So that's quite a number of grams, 6.6 moles. So the problem didn't ask us to do that, but just to relate what we're doing here back to one of the previous videos.